This is a video on solving radical equations. First, let's go over the steps to solve radical equations. A radical equation is an equation that contains at least one radical term in it. So the first step you want to do is isolate the radical term on one side of the equation. So we want to get one of the radicals on one side of the equation. Alright. Step 2, we want to raise each side of the equation to the power equal to the index of the radical. This will eliminate the radical from the equation. So basically we're going to take both sides and raise them to whatever power the index of the radical was. Meaning if I had a cube root, then I would raise each side to the third power. If I had a square root, I would raise each side to the second power. This will cause the radical to cancel out. Then you would like to combine like terms, and then solve for the variable as normal. Step 5 is very important. You want to check your solutions here. It's very common in this type of problem that you get an answer that doesn't actually satisfy the original equation. It doesn't mean you did anything wrong. By the nature of how we're solving these, it creates solutions that aren't true or that don't work in the original equation. So we'd have to reject those answers. Let's take a look at some examples. So for the first example here, we got 11 plus the cubed root of x equals 7. And our first step is to isolate the radical on one side of the equation. So I'm going to isolate this cubed root of x, right? That's the radical. I'm going to isolate that on one side of the equation. So in order to do that, right, what I really want to do is I want to move the 11 over to the other side. So the cubed root of x is by itself. So I'm going to subtract 11 from each side here. Subtract 11 and subtract 11. Now on this left side, the 11's cancel, and I'm left with the cubed root of x is equal to 7 minus 11, which is a negative 4. Now my next step here, now that the cubed root of x is isolated, is I actually want to raise each side to the third power, because it's a cubed root. So the index is 3, so I want to raise it to the third power. Whatever I do to one side, I got to do to the other. So you're raising both sides to the third power. The cubed root of x to the third power is just x. That's why we do this. A cubed root of something and that power cancel out, right? Cubed root to the third power, those cancel. They're inverse functions of each other. So this side is going to be x is equal to, here is negative 4 to the third power, which is negative 64. And we found our answer. Now remember, our last step was to check. Alright, and if you don't check this, you might get answers that don't make sense. So we had to check this in the original equation. So for my check, I'm checking 11 plus the cubed root of, now x is negative 64, just substituting it in, equals 7. Then you can evaluate this. This is 11 plus the cubed root of negative 64. The cubed root of negative 64 is a negative 4 equals 7. And then we get 11 minus 4, 7 does equal 7. So it checks out. So x equals negative 64 is our answer. Let's take a look at another one. For our next example, we want to solve 9 is equal to the fourth root of x plus 10 plus 6. So our first step, remember, is to isolate the radical. So I'm going to isolate this fourth root of x plus 10. The way I'm going to do that is to move this positive 6 over to the other side of the equation by subtraction. So it's going to be minus 6 and minus 6. 9 minus 6 gives us 3, and that's equal to the fourth root of x plus 10. Now once the radical is isolated on one side of the equation, remember what we want to do here is just raise each side to this fourth power, right? So if that's the fourth root, we got to raise each side to the whatever the index was, so the fourth power. Raise this to the fourth power. 3 to the fourth power on this side gives us a number. It gives us 81. That's equal to, on this side, the fourth root of x plus 10 to the fourth power. Well, the fourth roots and the fourth power cancel out, and you're just left with x plus 10. There really isn't a lot of work to do there. You just got to know that property. Once I'm here, I'm going to solve for x like normal, so I'm going to subtract 10 and subtract 10. So we got 81 minus 10 gives us 71 is equal to x, because those 10's cancel, and that would be my answer. Now remember, you got to check this though. Alright, we're going to check this in the original equation, so we're going to check it in the 9 equals. Alright, the fourth root of, this is x plus 10 plus 6. I'm going to check x equals 71, so we're going to have 9 equals the fourth root of 71 plus 10. And the plus 6 on the outside of that root. So we have 9 equals the fourth root of 71 plus 10 is 81 plus 6. And then 9 equals the fourth root of 81. Now that I've taken care of the inside of that, well, that's 3. So we got 3 plus 6, so 9 equals 3 plus 6, which equals 9. So it checks out, so x equals 71 is a good answer. Now if x equals 71 did not work, if this check came out incorrect, meaning it didn't work, we would reject this answer. We would put an X through it and we'd say reject, and then we would say there was no solution, right? If there was no answer at all, then we'd say there's no solution. Let's take a look at another example. So if you wanted to solve 4 plus square root of 5x plus 4 is equal to x. Again, our first step, isolate the radical. So I want to isolate the square root on this side of the equation. So to do that, I'm going to subtract 4 away from it. Subtract 4 over here. So I'm going to be left with the square root of 5x plus 4, because these 4's cancel out, is equal to, now over here we got x minus 4. They're not like terms. You got to leave them as not like terms. So we got x minus 4. Now that I've isolated the square root, remember you want to raise each side to the index of the root. Well, square root has an imaginary 2 here, so I want to raise each side to the second power. So I'm raising this to the second power. And you raise this whole side to the second power. The x minus 4, that whole side gets raised to the second power. You can't do it individually. You can't say x squared and 4 squared. You got to actually have these parentheses around the outside and say it's x minus 4, that whole quantity squared. On the left side here, the square root and the squared cancel, and that's why we did it. We get 5x plus 4 is equal to, on the right side here, if I have x minus 4, that quantity squared, remember what this means. It really means x minus 4 times x minus 4. And you, and you have to FOIL that. Alright, so we're going to FOIL this here, just for this side. So we're going to have x times x gives us x squared. X times a negative 4 gives us a negative 4x. From the inside, negative 4 times x gives us negative 4x. And a negative 4 times negative 4 makes us a positive 16. So we're going to get x squared minus 4x is minus 8x plus 16. And that's how I'm going to replace this left side of the, or this right side of the equation. So we're going to have x squared minus 8x plus 16. Now notice to solve this here I have a quadratic. Alright, when I say I have a quadratic term, I have something to the second power. If I have a value of x to the second power, it really means you want to solve this as you would solve any other quadratic equation. It means you want to get all the variables and numbers on one side and 0 on the other. So I'm going to actually solve this by, I'm going to subtract 5x and subtract 5x here. So I'm going to cancel these out. I'm going to be left with 4 equals x squared minus 13x plus 16. And I'm going to subtract 4 and subtract 4. So I've got 0 equals x squared minus 13x plus 16 minus 4 is plus 12. Alright, so that's our equation now. Now to solve this, you got to solve this by factoring. I'll do this on the next page. So taking a look on the next page, I'll just write out what we have again. So we have 0 equals x squared minus 13x plus 12 here. And to factor this, we have 0 is equal to. I can make two sets of parentheses right away. There is no GCF. I have 3 terms, and there isn't a number in front of my x squared. So right away I know I can make two sets of parentheses with x in the front of each of them. I need numbers that multiply to 12 and add to a negative 13. Well, numbers that multiply to a positive 12 and add to a negative 13 are a negative 12 and a negative 1. And now I want to solve this. So I set each of these factors equal to 0. X minus 12 equals 0. X minus 1 equals 0. Over here we'll add 12, and we get x equals 12. And over here we'll add 1 and add 1, so we get x equals 1. Now realize I got two answers here. You should check these to make sure that they make the original equation true. If they don't, we're going to have to reject them. So let's do our check, and we can check it right here. If we need to, we'll move on to the next page. So the first one I'll check is the x equals 12. Remember, I want to check this in the original equation. So going back to the original equation, I want to check it in the 4 plus the square root of 5x plus 4 equals x. Alright, so 4 plus the square root of 5, now we said it was 5x, so it'll be 5 times 12 plus 4 was equal to x, so x is 12, so I'm subbing 12 in there. And now we're just checking this. So let's be 4 plus the square root of, this is 60, 5 times 12 is 60 plus 4 equals 12. We get 4 plus the square root of 60 plus 4 is 64 equals 12. Now we can evaluate the square root. We got 4 plus square root of 64 is 8 equals 12. And then we get 12 equals 12. So that checks out. We also have to check x equals 1, our other answer. And for x equals 1, the same idea. We're going to sub into the original. So it's going to be 4 plus the square root of, now it's going to be 5 times, remember x is 1 now, so it's 5 times 1 plus 4 equals, remember, x, but x is 1 now. Alright, just substituting into our original. And now we'll just simplify this. We have 4 plus the square root of 5 times 1 is just 5 plus 4. Right, and this equals 1. We have 4 plus square root of 5 plus 4 is the square root of 9 equals 1. So this gives us 4 plus the square root of 9 is 3 equals 1. Well, 4 plus 3, that's 7. 7 equals 1. Well, that doesn't make sense. Since this doesn't make sense, that means x equals 1 isn't a solution. So we're going to have to reject x equals 1. And I like to just put an x through it showing that, you know, we're not using this solution. So the only answer is x equals 12. Right? Had the x equals 12 also been rejected, then there would be no solution. Right? So if there's an answer, then we say what the answer is. If all the solutions that we find get rejected, then the answer would be no solution. Right? Here's a couple for you to try on your own.